Hi everyone, welcome to this webinar. So my name is Davide Bazzafaro, I'm an Angular GD and an Engineering team member. It's great to see how many of you are connecting with us and joining us via YouTube. So we will start in a few minutes, but while we're waiting for other joiners, I'm going to share with you some very important informations. Yeah, let me share the screen. Okay. So mark your calendars for June 18th and 19th because this year Jerome is going to be massive. We are going to introduce another day dedicated to JavaScript and specifically to front-end world. So beside Jerome, which is already a full day dedicated to Jerome, we are going also to have JS Rome. As usual, we are also going to host a workshop day, the day before the conferences. Then we have the 18th JS Room conference, and then the 19th NG Room conference. Yeah, we already announced some speakers, and one of them is going to host the webinar. We are going also to announce soon other speakers, but actually the call for paper is already is still open and still you can still propose your papers. So yeah, so I invite you to go to our website and submit your proposal. And finally, yeah, we also have some tickets. You can go on the platform and check the tickets. You can buy the tickets for the workshop, or we also have some combo formulas for the workshops and the 2 days of conferences. We have some discounts for students. And I think that right now we still have, like the blind tickets are gone, but we still have, yes, the early bird tickets. So you can still get your ticket with a discount. It's going to expire, yeah, by the end of the month. So you still have some weeks to take the chance of getting the ticket for Jerome with a good discount. And I can assure to you that it's going to be really massive, and you don't want to miss it. So I invite you also to share, like to follow us on the social media, follow us on YouTube and also LinkedIn and X and other platform. I think we also have Instagram. So yeah, so in order to have all the information, we are going to announce soon again other workshops as well and other speakers. So I think we have already spent some minutes discussing about the conference, which is actually also the reason why we are here. But yeah, today we are also here for a webinar. And here comes Manfred. Hi, Manfred.
Hi, thanks for having me.
Yeah, how are you?
I cannot complain. Everything is fine, so thanks.
Are you happy to join us in Rome again?
Yeah, totally. It's a great conference. I think it's now my third time in a row, where I'm there in person. And I think before I was there once virtually, during the pandemic. So it's really a great conference. It's a great place to be in the middle of Bella Italia, of Roma. And yeah, so I'm really looking forward to it.
Yeah, is there still something that you would like to experience in Rome that you didn't have the chance the first times?
Well, I should really do some sightseeing because usually during a conference, I'm so tired that I'm not going out a lot. But I think I should really do it because the Eternal City has so many things to offer, and yeah, perhaps the Colosseum or something like this.
Yeah, I will really suggest you to take this chance. And if you need some help to book something, let me know. Yeah. Okay, so before I leave the stage to you, and you have already everything set, and yeah, you are the master of this webinar, I just want to give a quick reminder for our audience. So please write your questions during the webinar in the chat, in the YouTube chat. I and the other members are going to take notes of this, and we are going to share these questions with Manfred at the end of the session. There will be a dedicated Q&A session, so stay with us until the end. And again, write your questions so you don't miss the chance to have more information. So thank you, and Manfred, I leave the stage to you.
Awesome. So big thanks. Let me share my screen. And you should see my screen now. Yeah, looks good. Looks good. Ok, so mille grazie per l'invito. Oggi parlo di signal forms in Angola, and this is everything I can say in Italian. So let's switch back to English. So the idea of all of this is to give an advanced overview of selected topics, advanced topics in the area of signal forms, because it's such a huge library. We really need to focus on stuff that are most interesting for you. And for this, I've prepared an example application with a form like this one. And already here you see that this form covers several features like subforms. The entire form is subdivided into several components. It consists of a flight component, a prices component, and an aircraft component. Another thing you see here is custom controls. So my delay, my flight delay is a custom control, quite a simple one, where you can add 15 minutes or decrease the delay by 15 minutes. We also have form arrays, a repeating group. You can define several flight classes and a price for each of those flight classes. And if you define the same flight class more than once, you get an error message. That means you will see here how we can do a validation across all the items of such a form array. It consists of something you would call a form group in Reactive Forms, and we also have some metadata. We are telling the user upfront, before they are entering something wrong, that they are supposed to enter a value here that is between 3 and 30 characters. And this is also a little tiny starter into the world of metadata, where we can find out about what we are expecting from the user upfront and display it in this or that way. So regarding the agenda, I will give you a quick overview of the basics of signal forms. This will be quite short, about 3 slides, and this is for getting everyone into the boat. And after that, we will talk about selected advanced features like splitting large forms into several components, conditional validations. Sometimes when we enter a value here, this other value should be validated in a different way. Let's say if we select telephone number here, we need a different validator there compared to when selecting email address here. Conditional validation. Also, metadata, as mentioned before. We will talk about null and undefined values, which might be some challenge in the space of signal forms. And we talk about custom controls and why we do not need the control value accessor anymore. And we talk about interop with reactive forms, about a stepwise migration away from reactive forms towards signal forms. And this all will include a lot of live coding. In code veritas. So before we start, let me also introduce myself. I'm Manfred. I'm a trainer and consultant for Angola, and I'm focusing on Angola in the enterprise. In this role, I'm helping a lot of companies. I and my nice colleagues are doing trainings there. We are doing consulting there. We are doing reviews and development there. And besides this, I'm also quite connected to the Angola community. I live in Austria. I do a lot of stuff in Germany. And I'm always happy when I can work together with people around the globe, remotely or on site. Okay, so let's get started with the basic of signal forms. Just a quick overview. And to make this a bit more exciting, I have this data model that you have also seen indirectly before when we talked about our example. It's about flights, and each flight is connected to an aircraft and also to several prices to cover different flight classes, like, business class, premium economy, and so on. So to set up a signal form, we need, of course, a signal. Here it's a signal of flight with this primitive data and with a connected aircraft. And in there, where we have these ellipses, we also might have some prices. So once you have your signal with your data model, you pass this signal to the form function, which is the central helper function of signal forms. It returns a data structure that is representing this data here as a signal form, or to be more precise, as a so-called field tree, a field tree of flight here. So you can think of a field tree as a deeply nested signal, a signal that consists of signals that consists of signals. Signals for the ID, for from, for do, for the aircraft, but underneath this level, also signals for the aircraft's type and registration. And for all those levels, we have form data in there. Not just the value, but also information like, is it valid? Has it been validated correctly? Is it dirty? What are the validation errors? And so on. So we see how to use this field tree by hand here. You can grab the entire form, the field tree, and go down to the level of a field like from the airport of departure and check whether it's valid or whether there are errors or what's the value. Or we can go one level deeper to the aircraft and its registration to find out whether it's valid, what its errors, and what's its value. So basically a deeply nested signal with form data. You can bind this field tree or parts of it to input fields and select boxes and so on using the form fields directive. And interestingly, as signal forms is really type safe, we even here need to define that the ID has type number. It really even tries to be type safe when it comes to the connection between HTML and signal forms and TypeScript itself. We can also pass a schema. So far, we only passed the data, but we can also pass a schema, which is basically another function that gets this path here. And this path can be seen as some kind of laser pointer, pointing to one of the nodes of your deeply nested signal, to one of the properties in there at the first level, at the second level, and so on. Here I'm pointing to from on the first level. I'm saying, hey, from is required, and we have a min length of 3. This is a tiny schema, but if it grows a bit bigger, it's very likely a good idea to put this schema into a file of its own. This is something you will see in my examples. And also there, when we bind this guy to our input fields, we can find out about the validation errors the user produced by looking into the error signal of this or that field. Here I'm just presenting it using the JSON pipe, but in my example we will use in some minutes, I have a component of its own. A very simple component that is converting this data structure into nice error messages that are presented one after each other. And that's it for the beginning. So as you have seen at the end of the day, signal forms really deserves its name because it signals all the way down. That means we can proceed working with signals even when it comes to the connection to the form, to the form the user is reading, but also the form the user is modifying. And once the user starts modifying something, the values are written back to the signal of origin, and it's also validated as seen before. So now let's talk about splitting large forms into tinier pieces, because chances are that you have quite a lot of forms in your enterprise applications and they should stay maintainable. So usually you need to split them into different tiny parts. And this is what I did in my example. We already discussed this before. My example has a first part, which is the flight itself. It's the header, if you want to put it that way. It's a first component. Then we have another component for the prices, for this repeating group, for this form array. And we have a third subcomponent for the aircraft. So let's have a look to the implementation of this. Let's jump into the source code. Let's open my flight edit component, and here we go. So this is my Angular component, flight edit. It contains a lot of stuff, but the only thing for now that is important for us is that we have here our signal form, our field tree of flight. You see here is a field tree of flight because we are passing in a writable signal of flight. This writable signal comes from a store, and this already gives us our first challenge. Because usually when a store gives us a value, it's read-only. Makes a lot of sense, because the store needs to make sure that not everyone is messing around with the values. On the other side, the form wants to bind back to our fields. It wants to update the fields when the user is changing something. And so we have a dilemma. We need both read-only signals and writable signals. And to solve this dilemma, I'm going with a linked signal, which is basically a computed signal with a local working copy. The result of a linked signal is always a writable signal. You see it here. I can write back to it, but I'm only writing back to its working copy, not to its source. I'm not directly writing back to the store. For this, the store is giving us some well-defined methods. And saying this, then I'm doing this conversion, I'm also converting a bit my flight object using normalize flight. It's a very simple function that is just tweaking the date format, because the date box I'm using, it's just a native date time local date box, needs the date string in a very specific format, an ISO string without any time zone information. So this is what's happening here. Okay, so long story cut short, at the end of this, I have a writable signal. I can put it into my form helper, and I'm also putting in my schema with validation roles. We will have a look to it a bit later. This ends up being my field tree of flight. And now when we look into the HTML of this, we say, well, this HTML is really beautiful. It's really cleaned up. It's just a form consisting of 3 parts, 3 subforms, and a save button. The first subform is the flight itself. Then we have the prices, and here we have the aircraft. And as you can see here, I'm just putting down parts of my field tree to those subcomponents. It's really as easy as that. When it comes to the aircraft, I'm putting down a field tree of aircraft. When it comes to the prices, I'm putting down a field tree of price array. This also shows that a field tree consists of field trees that may also consist of, field trees. So if we look into our aircraft component, what we see here is it basically has an input, a signal-based input, a required one, of type field tree of aircraft. And this input is used inside the HTML. As the aircraft is an input signal, I need to unwrap it. I need to call the getter. And this gives me my field tree of aircraft. Here I'm just calling it aircraft form. And then I can proceed with data binding to it, to the type of my aircraft, here to the registration number. As seen before, for this I'm using the form field. And I can even work with the errors on this or that field level. Here I'm not displaying the errors using the JSON pipe. Here I'm passing it to a very simple subcomponent that is just displaying all the errors in there in a nice way. When it comes to the prices, it's about the same. Also, prices is just a component with an input signal, a required one, an input signal of field tree of price array. I have an add method to add further prices. And then in my HTML, I'm doing more or less the same. I'm unwrapping my input signal. I'm calling the gather, which gives me my field tree of price array. And then I'm iterating over it. It's really that simple. So compared to form arrays in reactive forms, this is really, really straightforward. I've used form arrays quite a lot, and quite often I had to look it up because somehow it was not that logical for me. But this is really drop dev logical. Just iterate your array and that's it. So here I'm iterating all my prices, and for each price I'm defining a new table row with an input field for the flight class and another input field for the amount. So if we try out this example, then we see we even have a validation on those lower levels. The type and the registration, for instance, both are required fields. So let's type something into it. I also have a validation here. For instance, the flight class needs a value. Let's say value 1 is 300 euros, value P is 400 euros. And then by mistake, I'm repeating class B, which gives me another error message telling me, hey, you can only have one class for one time. So don't go with two separate prices for the same class. This does not make sense. So now the big question is, how can we define such validators on those lower nested levels? For this, I'm switching back to my source code. And here we remember, we were calling the form function. We were passing our writable flights array and a schema. Now let's have a look into the schema. It's defined in a file of its own. If it is a general purpose schema, you can place it next to your data models. And here you see the schema is basically a schema of flight, which consists of this, this function here, this lambda expression. We are getting a so-called schema path tree of flight, which is one more time our laser pointer pointing to one of the nodes in this nested data structure. And by pointing here or there, we can define that this or that field is required or that this or that field has a min length. But we can do even more. We can say, hey, let's apply another schema to path.aircraft. Perhaps we have another schema that describes how an aircraft should be validated. And here I'm connecting it to path.aircraft. And if we look in there, it's just another schema. One more time, type schema of aircraft. One more time, a lambda expression. One more time, the laser pointer. And so we can point to this or that property to define validation rules. We are doing almost the same with all the prices in there. But when it comes to the prices, we have an array. That means what we really want to do is we want to apply this schema to each and every entry of the array. And this is exactly where apply each comes in. So if we want to apply something to each and every entry, let's go with apply each. If we just want to apply something to one sub-object, let's go with apply. Or to put it another way, if you had a form group in reactive forms, apply would be your friend. Otherwise, if you had a form array, apply each is your friend. And besides this, you can even define a validator for an entire forms array like prices. What you see here is a custom validator, which is basically a function. It's really that straightforward. A custom validator in Signal Forms is just a function calling the general purpose validate method or function. And this validate function gets what to validate, our laser pointer, which is here the prices, and here another function that defines how to validate. In there, we are getting the current context, and this context gives us access to the value to validate. Here, the value is our prices array, but it also gives us further information, like information about the state. Something like, is this field dirty? Is it disabled? Why is it disabled? Which errors do we have? And so on and so forth. Somewhere down there, we have valid, touched value, and so on. I guess most of the times you need the value itself. Yeah, and then you can validate the value. And if there is an error, you return an object like this. At least it needs to have a kind, informing about the kind of the error you've detected. And besides this, you can add any possible further property to describe your error. A message, but also something that is as concrete as the flight class. If you did not find an error, you are just returning null. No praise, no feedback is praise enough. Not complaining is praise enough. Something I learned in Germany several years ago. Okay, cool. So in this case, I'm going through the prices. I'm collecting all the flight classes I've seen in a set. And when I have seen something twice, I'm returning an error message. That's it. So basically, another function. Yeah, this is all we need to do to define that we want to validate the lower levels in a specific way. Yeah, awesome topic. I think this was also the biggest topic, the topic about splitting a big form into subforms. It's also an important topic for me because, as mentioned, usually in a big enterprise application, you have a lot of forms and sometimes you need to make them manageable. You need to break them down. Okay, so let's talk about conditional validation. Here I have a very simple form of conditional validation, but please see it as a proxy for all the other more complex forms of conditional validation, where the kind of the validation for this field depends on the value of that field. Here I have delayed, and once delayed is checked, it needs to have a minimum amount of 15 minutes. Because in the country where I live, in Austria, everything below 15 minutes is perfectly fine, is perfectly in time. Being too late only starts with a delay of 15 minutes. So no validation when it's not delayed, and the validation for 15 minutes when it's delayed. A very simple example, but out there are more complex ones, like when I'm selecting telephone number here, this needs to be a telephone number. If I'm selecting email here, this here needs to be an email. Okay, let's have a look into my demonstration. So here, a delay of 0 is fine, but when it's delayed, we need to have at least 15 minutes. And yeah, then we can go on here. How was this implemented? Well, perhaps you have already seen it in my example. For cases like this, we have here functions like apply when value. I'm passing in what I want to validate. Here it's my entire path, my entire flight. It could also just be a part of it, the aircraft or something below this level. But here it's the entire flight. Then here I have a predicate that tells us whether we want to apply our validation. So if this here returns true, then this validation is applied. In my case, it's only applied when the flight is delayed. And to apply the validation, we are using this scheme here, this schema, delayed flight, where we say, well, the delay is required and it needs to be at least 15 minutes. If this here is not true, which might be false, then this schema here is ignored. Okay. So let's also talk about metadata. This is really a big new possibility. We did not have something like this before, at least not in an official way. Metadata is all about telling the user upfront what they are supposed to enter before they enter something where they get an error message for. For instance, here the asterisk tells us this field is required. Or here we are seeing the min and the max length. Or here we see that they are supposed to enter a valid city name. So how to work with metadata? Well, for this, let's go back into my application here. And let's have a look into my flight form. The flight form is displaying my header, like the flight ID, from, to, and so on. And in addition to the label like from, we also have a call to field metadata pane. So let's have a look into field metadata pane that gets our signal, our form tree, field tree for from in this case. So in there, I'm getting in my field tree as an input signal. And now we have a little tiny challenge, because now we have a signal in a signal. We've discussed before the signal, the field tree itself is a signal, but also the input signal is a signal. That's why we need to call the getter twice. It's not that beautiful. We need to call the getter twice, once to unwrap the input, once to unwrap the field tree. I'm calling this the swollen eye operator because it looks a bit like my swollen eyes after coding the entire night. And because this is not that beautiful, I'm hiding this in a computed. So I only have this in one line, and after that, it's a bit more beautiful. After that, I have my unwrapped field state. This always reminds me to those jokes some people do when someone has his or her birthday, giving them a box with a box inside that has another box inside and another box inside. I remember when I was a child, one of my friends gave me such a box, and back then I was quite tiny. I did not understand the humor of this. Meanwhile, I really find it funny. Okay, cool. So field state, the unwrapped field state. So the thing is, once we have this field state, this signal on the right level, we can ask it, do you have some metadata for us? And by asking this, we need to pass in a metadata key, which is just a constant. And if there is some metadata, we get it back. If there is no metadata, we are getting back undefined, and that's why I'm going with a default value here. And it turns out that Angular and all its validators come with a lot of predefined constants, metadata keys, and all those validators set the metadata automatically. So we don't need to do anything, because when we call required, Angular itself knows, well, this is a required field, so it sets the metadata. Same for min length, same for max length, and so on. We can also define our own metadata keys. It's just a matter of defining a constant. We will see it in 1 minute or 2. So what I'm doing here is I'm just requesting the metadata, and then this component is displaying it. And that's why in my example, here we see an asterisk and we see 3 to 30. So now let's also set the metadata key for city. For this, I'm going to my flight scheme. And here, to get started, I'm setting the metadata by hand, just by calling metadata. I'm passing in my laser pointer, the level I want to define metadata for, like from. I'm saying, well, this is all about the key city, and this is the value. That can change. And here, let's do the same for 2. So this key value pair is defined internally, and that's why my component is now also saying, hey, please enter a city here. Okay, so the big question is, how can we define our own metadata keys? Well, it's just a constant created with create metadata key. In the case of city, it's a metadata key of Boolean. And I think in most cases, this is good enough. However, if you really want to be on the safe side, you would think about a special case where you have a first validator, let's call it city, validate city, that defines city true, and another validator, like let's call it validate max length, that sets city false. So now they are competing over the same metadata field. And the big question is, who is the right one? Who wins this competition? And by default, if you do nothing else, then the winner is the last one. I really appreciate this. As an Austrian, Austrians always lose at soccer. So this would be a nice rule at soccer. The last one wins. But if you don't want the last one to win, you can, and you see this here, create a metadata key with a reducer. And Angular itself gives you some reducers out of the box, like an OR reducer, where all those booleans are ORed. True or false is true. Or you can AND it. Or you can define a list where you get true and false, an array with both values. And as you see here, you can even define your own reducer. This here is my very own OR that checks whether X or Y is true and then returns the result of this. So you have a lot of possibilities in there. Perhaps no reducer is good enough for you, no explicit one, or perhaps even the built-in ones are good enough for you. If they don't work, build your own. Okay, so as mentioned before, you can define the metadata by hand, but usually you don't do this. Usually you just call some validation function like a custom validator, validate city, path.from, where I say validate it against the most important cities on this planet, like Graz or Berlin or Rome. I think that's it. And now this validator can internally set the metadata. Let's look into it. Here you see one more time, I'm delegating to the validate function, and the rest looks as before. But before I'm doing this, I'm setting the metadata, because if something is validated against cities, it's supposed to be a city. Okay, one more time, let's check it out. Yeah, it's still a city. Okay, no Outlook. Let's go back to PowerPoint. And let's have a look into another topic, null and undefined values. So it might come as a surprise that signal forms do not support undefined. If you do something like this here, not delay, but delay, delay with a possible value of undefined, you get some errors from the Angular compiler. And this is by design, because undefined at the end of the day means this field does not exist. It does not exist. However, signal forms, especially the form helper function, needs to build a data structure for your signal. So it needs to get some information of all the values and the nested values. That's why undefined, which means this field is not there, is very counterproductive. So don't use it. You might have another challenges with null, because you don't see what's underneath it. Saying this null is allowed. For very special cases, null is allowed, but you should really avoid null, because at the end of the day, you cannot look into the value. Especially if you have several nested levels, you cannot look into null, because null means there is nothing. And also typing null is so difficult. So undefined is not allowed, and usually you should also not use null. So what to use instead? Well, if we look at this from a forms perspective, delay is not optional. If we look at this from a forms perspective, you always have a delay field. It might be hidden. It might be disabled. It might have a value that means null, but the field itself is always there. And that means you need to distinguish between two views. The view on the form level and the view on the, let's call it, domain level. I have it here. On the domain level, the delay might be optional. Perhaps your backend does not allow a delay in several circumstances. But for the form, you always have a delay. As mentioned, perhaps it's read-only, disabled, perhaps it does not have a value, but there's always a delay field. So the right way to model it would be to define two separate models and to convert between them, which is not that difficult in most cases, because it's just a matter of a simple function. And doing this, you model both points of views in the right way. And also, this is nothing new. If you dealt with architecture, with distributed systems, you have this topic all the way down. You have one representation for your data in the database. Often you call this the entity. You have a domain object or a business object. You have a data transfer object. You have a view model. Now you also have a form model. So different representations on different levels of abstraction. This is the right way to do it. Keep this in mind. Now, let's also talk about custom controls. So in my application, I have a simple custom control. Also, this is meant to be a proxy for more complex ones. I have this delay stepper that allows me to increase or decrease the delay by 15 minutes. Let's have a look to it. Let's go to my flight form. And here you see that I'm calling my delay stepper. And this delay stepper gets my field using the form fields directive. So even though this is a custom component, I can use signal forms with it and the entire validation chain and so on. So how does app delay stepper look like? In former days, to make this work, we needed a control value accessor. And I never did a survey, but my impression is it was never in the top 10 list of Angular's most favorite features. The control value accessor was always a bit special. It felt like an internal API, very likely because it mainly was an internal API, and yeah, it was a bit special to use. So the good message is to make this work with signal forms, all you need is just an model signal of with the name value. That's it. Define a model signal that is called value and pops your uncle. This value is defined by form value control. We implement it here. In our case, it's a form value control of number because I want to represent a number with my delay stepper, the delay itself. This is everything you need. Besides this, there are some optional fields like is this disabled or are there some errors? If you look into this type here, you see, well, it's extending this further type and it always has a value and never checked because for checkboxes there is another type. And if we look in there, we see there are a lot of optional fields we can implement to find out about our current field status, like errors, disabled, the reasons for being disabled, read-only, hidden, invalid, pending, Dutch 30, and so on and so forth. All the stuff you already know from the other form models. For the sake of completeness, besides form value control, there is form checkbox control. It always contains checked and never a value. So implement those interfaces, at least one of them. They give you one mandatory field and a heap of optional fields you might want to implement. And that's it. One last topic, a last topic, but also a very important one, interop. Interop between the good old reactive forms world and signal forms. So let's say you want to do a stepwise migration. Business applications are never migrated in a big bang. That does not work. So we need to update our application little by little. And here we might already have a signal form, but perhaps a part of it is still a reactive form. This is something you can do with the compat form. So let me show you this by moving over to check-in, where this here is, as mentioned, a reactive form, and the outer one is a signal form. How does this work? For this, I'm switching over to check-in page. And in there, we have our form builder that gives us a form group for the passenger info. The passenger info with first name, last name, and email. This is our passenger group, our form group. And then, and this is now really special, we have a signal, our check-in form model. And as this signal is used with signal forms, it has some values here, key value pairs like ticket ID or conditions are accepted. And besides this, we are pointing to our passenger group, to our form group. So it's a hybrid of both worlds. And to make this work, we now call compat form instead of form itself. We are passing in our model, we are passing in our validators, at least the validators for the signal form part. The validators for the passenger group part can be set up directly in there. And then we can data bind both. We can data bind. We can data bind. We can, come on. We can data bind the ticket ID in the signal forms way, the form field, and the passenger group, which its fields in the reactive forms way, the form group and form control name. So now you might say, yeah, this looks like two different forms. Why do I need the compat form? Well, the reason is that even though we have two different forms here, the state from the inner form is propagated upwards. So if we have a validation error in there, we get here on this level the information that the form, this hybrid form, is not valid. So the valid state is propagated upwards. We get the same for the dirty state, for instance. And this in turn then tells us that we are not allowed to move on with the check-in. So this here shows how to use reactive forms inside of signal forms. Meanwhile, the Angular team is also working on the other way around. I've seen a pull request where it was possible to use signal forms inside of reactive forms. And this gives us a nice way to migrate over little by little to the new world. The Angular team really holds up to their values. Your investments are safe. You don't need to hurry and worry. You can stick with the current stuff you have. And if you want, you can do a stepwise migration. Perhaps according to the Boy Scout rule, perhaps you just want to improve everything you need to touch anyway. Okay. So before we come to the Q&A, let me also remind you that you will see more about this at Angie Rome in June this year. I will be there for giving a talk, so it's a great opportunity to meet in person. And I also do a workshop with my colleague Rainer. It's a full day's workshop. It's our newest version of the Angular Architectures workshop. And we really cover a lot of new stuff and use it for implementing long-lasting architectures. We are using the new signal store, signal forms. We are even integrating an AI assistant into our application, which is also tying into the architectural level quite a lot, because an AI assistant like Copilot needs to talk to the store and to other parts of the system. So this is really interesting. We also see there how to enforce a given architecture, how to work with a monolith and or micro frontends. So check out this one. Get your tickets now. There is currently an early bird. It will end soon, so make sure you book your tickets very soon for you and your colleagues. Okay, so let me come to the conclusion. We have seen today that signal forms come with a quite natural API. It's quite easy to split the entire forms to several different components, and it's also easy to work with arrays and groups. We have seen that you can do conditional validation. Under some circumstances, you can apply additional validations. We have seen we can work with metadata, a completely new possibility. Was not possible before. We can tell the user what they are supposed to enter before they enter it, before they get an error message. We have seen how to deal with null and undefined values. we have seen that it's drop death easy to deal with custom controls, and there is some interop to bridge between the worlds. Your investments are safe, and you can start using signal forms for new stuff or stuff you have to touch anyway. And that's it. I've already uploaded my material, my examples, and my slides to my blog here. And follow me on social media to stay in contact. Thank you.
Back again. Thank you, Manfred, for the session. It was really amazing. You received so much, like a lot of questions, but you still have time to submit some. I received some questions actually privately, so I will try to like translate those better than I can. So the first one, it's about how we're going to migrate the forms that actually depends a lot on Eric's operators, such as the bounce, switch map, distinct changes, and stuff like that, basically.
Yeah. So if you depend a lot on RxJS for, let's say, the bouncing or switch map, you can currently work, of course, with an effect that is triggering something when the form value is changing. Or perhaps instead of an effect, you might use some other reactive primitive. Perhaps you are directly connecting your form to a resource for loading something in addition. And then you will have switch map semantics. Or perhaps you connect it to a method of your state management. And this is a bit cleaner than an effect because this gives you a nice, end-to-end reactive flow into your form, but also the changes out of the form to a resource, to your signal store, to some methods there. And that's why all those topics really come together. We need to look at them together, not just looking at signal forms in isolation. We need to use them together with all the other signal-based stuff, like signal-based state management, the NsureX signal store, for instance.
Yeah, makes sense. They are like connected topics, and basically you can get really nice advantages using all those together. Yeah, thanks. There is actually another question, and it's more about the interoperability. So basically, like, are there any advantages of using the combinations of reactive forms and signal forms instead of just, I don't know, stick for some time a little bit more on just reactive forms and then do a massive migration later?
Yes and no. I mean, the main advantage is that the state is propagated upwards, even though it's a hybrid. Of course, you don't need to use it, but if you have a lot of subforms, then you have this issue that you start migrating here. And because of migrating here, you find out, oh, I also need to migrate there. And now I also need to migrate at this other component. And this, let's call it cascade, can be interrupted by this hybrid mode, so that everything you need to touch is updated, and then you stop the cascade by applying a hybrid at some level where you need both the old and the new.
Yeah, no, with the example of the subforms, I totally see also the need or like the chance of using the signals from inside the reactive form. That was what you were talking about. But yeah, of course, you can also do the opposite, so it makes sense. Yeah, I don't see any other question. So yeah, I will say, since that everything is fine for now, and yeah, if there will be other questions, they can take those and bring those to Endurum for sure.
Yeah, of course. Would be great to meet there, and discussing questions in person is always a bit more pleasant.
Yeah, totally. Okay, so thank you for being with us today and for this amazing webinar, and I hope that we will see soon. Okay, no, last question. Someone asked if the plant that is behind you is real or not.
Oh, no. I have a black dump, so that's why it's completely artificial. It's just plastic.
Nice. Thank you for answering. Okay, so wish you a good rest of the day, and thank you for being here with us.
Yeah, thanks for the invite.
Thank you. See you in Jerome and on June. Thanks. Ciao.
See ya.